finding the best attribute to split a decision tree, it's the most important factor. So we cannot just randomly select an attribute and based on that we keep splitting. Okay, it will work, but it will give poor results in classifying, identifying, in future samples and things like that. So let's consider this, the same tree we have considered before, the risk of heart attack. I have changed a little bit. I have said that instead of weight, this is the BMI, and if anyone has less than 25 BMI, they're low risk, and more than 25 considered obese, and they are always at a higher risk of heart attack. So let's say this is a data set. Okay, do not try to directly, calculate mathematically that how this tree, this data maps to this tree. These are just I have created, intuitively just to show you the relation. So this ID number is just the records 1, 2, 3, 4, 5, and many others, age, BMI, whether alcoholic or not, and the risk associated with it. So we are actually given this data set. Okay, there will be multiple features here, just 3 features: age, BMI, and alcoholic. And based on that, we do a categorization of the risk, high or low. That is a binary classification. But in practice, there can be multiple attributes, or the n number of attributes. The n can be a pretty large number. In that case, how to find which is the best attribute, which should go in the root level, at the next level, any other decision level. How to find that is a very important thing. So to build a decision tree, the major decision we need to make is that which attribute should be chosen next to split the data. Okay, so to select the best feature, the attribute, we use attribute selection measures, or ASM. And there are many different types of ASM, or attribute selection measures. So what we do based on the attribute selection measure, whichever is the attribute with the highest value, or lowest value, in case we want to care for minimizing or maximizing, we choose that particular attribute which comes out and then place it at the root or any other intermediate decision making level. Okay, and then further split the data into many subsets and grow the tree, or make the tree bigger and bigger, deeper and deeper. So we recursively follow this procedure until one of the conditions are met, like all the tuples belonging to the same attribute value. That means we divided, and under that, or whatever the records, they are all coming to low risk, and then we don't split it anymore. I mean, we know that, okay, these are similar kind of persons, have same outcome, or there are no other remaining attributes to split with. We can stop there. Also, if there are no more instances, all the data we have been thinking about classifying all the training data have been finished to be considered. So then we stop. So there are other concerns like overfitting of the decision tree, and there will be some levels and other the height of the tree, this kind of thing we'll be considering, but that we are not discussing here. Okay, so now we talk a little bit about what are the ASMs, the attribute selection measures. So there are some standard attribute selection measures like the entropy, the information gain, Gini index, or gain ratio, reduction in variance, or chi-square. There are different different types of mathematical parameters which are considered by different algorithms. Okay, entropy is a property given by the Claude Shannon. We'll talk a little more about it here. We just introduced the concept. So entropy is the measure of the randomness. Okay, let's say we toss a coin. So the probability varies from 0 to 1, okay, for a head to tail or tail to head, whatever you could say. So, but when the probability is 0 or 1, we know that definitely, okay, this is head or tail, and similarly for 1 also. But when the probability is 0.5, we do not know what will be the outcome. Okay, that's the maximum amount of randomness at 0.5. So we say that the entropy is the highest. Okay, so where we cannot determine perfectly what will be the outcome. Now, what is the information gain? Information gain is used by the ID3 algorithm. ID3 is the iterative dichotomizer algorithm, and information gain is kind of opposite to, intuitively opposite to the entropy. Entropy is kind of the measure of the randomness. Information gain is it's a statistical property that measures how well a given attribute separates the training examples. So according to their target classification. Okay, constructing a decision tree is all about finding the attribute that returns the highest information gain. Okay, so we want to here we want to maximize the information gain. and minimize the entropy. That means it minimizes the randomness and maximizes the predictability. That's the idea. Okay, so information gain is basically about decreasing the entropy. Computes the difference between the entropy before the split. So we'll calculate the entropy before we make the split at this level, and after we make the split among the subgroups, we'll calculate the entropies and kind of add them together, and then subtract this before and after thing, and then we'll say after doing the split, did we reduce randomness? That's the question information gain tries to ask. Okay, information gain computes the difference between entropy before split and average entropy after the split of the data set based on the given attribute value, and then whichever gives the maximum information gain, that attribute is chosen to split the data. Okay, so that Gini index is another property. We'll talk about it a little more. The CART algorithm uses Gini index. Gain ratio is used by C4.5. Okay, so this is an improvement upon the ID3, which is C4.5 is also known as J48, the Java implementation of the C4.5, which is in the Weka toolset. You will find that's a J48. It's the same thing. And there's a reduction in variance is used for the regression data, the continuous variable prediction, where we are calculating the the continuous target variable. We will use the normal formula of variance, the standard formula, and then choose the best split, which kind of lowers the variance. The split with the lower variance is selected as the criteria to split the population. So every time we want to split, we see that variance is reduced and reduced and reduced. So that means we very confidently we can say, okay, this group of data are similar. That's the idea. Okay, they vary less. And then the chi-square is used by the CHRD algorithm, and these are the standard standard attribute selection measures, and we'll talk a little more about them to see how they can be used to classify which nodes should be split.